in two sections. In the first section, we will learn all the math concept which is related to exponents. Once we're done with that, we move on to the second section, practice question. We will solve only official material questions. Why official material questions? Because you will get the same type of language and question format for the real GRE exam. Therefore, we will avoid all the third-party material. There are overall 5 official materials are available for the GRE exam. Exponents. Exponents are the repeated multiplication of a certain number. Let's say you got an expression like this, 5 to the power 3 or 5 raised to 3. So whatever the number we have written, the down part is known as the base number. Whatever we have written upper part, it's known as exponents or power. So what is the meaning of 5 raised to 3 or 5 to the power 3? Means whatever that base number, that is 5, we have to multiply this many times, that is 3 times. So 5 cube means 5 we are multiplying 3 times. 5 times 5 times 5, that is 125. Okay, what about 2 raised to 4 or 2 to the power 4? So whatever that base number, this is base number, that's 2. How many times we are multiplying? This many times. So 2 we are multiplying 4 times. 2 times 2 times 2 times 2. That will be 16 here. Now what about a square? It means this letter A we are multiplying 2 times, that is a times a here. Now there are certain rules we have it for exponents which we already know. So these are the basic rules for the exponents. Now we will try to understand one by one. So let's say you got an expression, exponential expression like this, x to the power m times x to the power n. Then this is the expression you have to remember, x to the power m plus n. So what we are trying to say, whenever we are getting an exponent and you are multiplying these two exponents, and what about if the exponent's bases are same? Then you just add, if the bases are same, here the letter x is the base, here also x is the base. So we know that the same base, then what we try to do it, we will add the exponents here, that's m and n, we will add it m plus n. Now let's try to understand what's the meaning of it, and let's try to apply this rule here also. Let's consider 2 to the power 4 times 2 to the power 3. So if I follow this rule, all I see bases are same, then we are multiplying two exponents. Then I can see, bases are same, therefore I can just add these two exponents, that's m plus n. So it will be base is 2 and this is m, this is n. So this will be 4 plus 3, that's 7. Now let's try to understand what's the meaning of it. So we know 2 to the power 4 means we are multiplying 2 4 times. 2 times 2 times 2 here. Now times 2 to the power 3 means 2 we are multiplying how many times? 3 times. 2 times 2 times 2 here. Now I can write this entire expression as an exponent. Exponent means it's a repeated multiplication of the same number. So if I look at here, how many times we are multiplying 2? 1, 2, 3, 4. 5, 6, 7. So actually it's 7. So I hope it makes sense how we are getting applying this rule, right? So whenever we are multiplying two exponents, if the bases are same, then we will just add the exponent, that is 4 plus 3. That's how we got 7 here. Now let's try to apply the same rule here. So 5 square or 5 to the power 2 times 5 to the power 4 here. All I know, the bases are same and I am multiplying two exponents. Then I can see that I can just add the exponents part, this upper part, 2 plus 4. 2 plus 4, that's 5 to the power 6 here. And it makes sense, 5 to the power 2 means 5 we are multiplying 2 times 5 to the power 4. 5 we are multiplying 4 times. 5 times 5 times 5 here. So I can write it, the entire expression as exponents here. 5 we are multiplying how many times? 2 here, 4 here. So overall, that's 6 times we are writing here. So that will be 5 to the power 6. And I hope it makes sense, this rule. Now what about this? 8 to the power 5 times 8 to the power 2. Same rules. If you apply logic also, you will get the answer. Here A we are multiplying 5 times. Here A we are multiplying 2 times. So overall, how many times? If I use logic, A overall we are multiplying 7 times. So I can say 8 to the power 7. If I apply this rule, bases are same. That's A. Then you just add the exponents, 5 plus 2. That will be 8 to the power 7 here. Now let's consider the second rule. Now same rule here, dividing an exponent. So whenever we are dividing an exponent, if the bases are same, x to the power m divided by x to the power n here, all I see the bases are same. Then what happens if it's a division? We just subtract the exponents here, that will be m minus n here. Now let's try to understand the reason behind here. 3 to the power 4 divided by 3 to the power 2 here. So then I can say 3 to the power 4 means 3 we are multiplying 4 times. What about 3 to the power 2? 3 we are multiplying 2 times, and it's cancelling out. What is remaining here? 3 times 3, that's 3 square. And same rule, if I apply it here, all I know the basis is 3 here also same. Now it's a division, I can apply this rule. So what is the rule? So if you are dividing an exponent, if the bases are same, then you write base here 3, then m, this is n, then it will be m minus n, that's 4 minus 2, that will be 2, and I hope it makes sense. So what will be the answer for this expression? All I know here, the base is 2, I know base, the same number you're getting, and it's a division, then I can apply the rule, whatever that base, then m minus n, this is m, this is n, that will be 6 minus 2, that will be 2 raised to 4. And I hope the logic behind here. So what happened here, 2 to the power 6 means we are multiplying 2 6 times, 3 times, yeah, 6 here. Now to the power 2 means 2 we are multiplying 2. So it's cancelling out. What is remaining here? 2 we are multiplying 4 times, that's why we are saying 2 to the power 4. Same rule if I apply here, this is a letter here, s to the power 12 divided by s to the power 4. Same if I apply the rule, the bases are same letter, s, then it's a division, so it will be m minus n, 12 minus 4, that will be 8 here. Now let's look at the third rule here. That's power of a power, right? And well, let's say you got an expression like this, x to the power m raised to n, right? Then you can say that, then you can just multiply these exponents, that's x to the power m times n. Let's try to understand the logic behind it. So for example, why we are applying like this, right? Power of a power, when we are getting an exponent, then what happens? We just multiply the exponents m times n. Now let's try to understand what's the reason behind it. Let's say you got an expression a squared means a we are multiplying 2 times here. So if I look at this expression, 5 to the power 3 raised to 2, what's the meaning? So you can just consider as just one number. 5 to the power 3 means and it's square, right? So you can say 5 to the power 3, how many times we are multiplying? 2 times. That's the meaning of this exponents, right? So 5 to the power 3 times 5 to the power 3, and if I apply the same rule, right, x raised to m times x raised to n, that will be x raised to m plus n. Because the bases are same, I can say 5 to the power m plus n, 3 plus 3, that will be 6. And that's the same rule here, right? All I can see here, x to the power m to the power n, I can say x to the power m times n, right? Same thing, 5 raised to, this is our m, this is our n, then it will be 3 times 2, that will be 5 to the power 6 we are getting. I hope it makes sense also. Now, what about then? What's the meaning? 3 square, how many times we are multiplying? 5 times. If I use the logic, right? 3 square times 3 square times 3 square times 3 square times 3 square, right? So I can apply the same rule, x to the power m times x to the power n, that will be x to the power m plus n. So the bases are same, you can add all of it, right? So 2, how many times we are adding? 5 times 2 plus 2 plus 2 plus 2, that will be 10. And it makes sense also. If I apply this rule, this is x to the power raised to n, right? So I can say 3 raised to m times n, that's 2 times 5, that will be 10. It's the same answer. What about this? It will be a cube, we are multiplying 4 times, or if I apply the same rule here, it will be a raised to 3 times 4, that will be 12, a to the power 12 here. Okay, now let's consider the fourth rule here. Product of an exponent, right? So you just use the common sense, you will get the answer here, right? So whenever we are getting an expression like this, let's say there is a parenthesis, right? X times y, the whole raised to n. Then I can just distribute this n separately, right? So then I can say that x to the power n times y to the power n here. Let's try to understand the logic behind it. Now, if I look at here inside the parenthesis, what is inside? AB, right? A times b square. What's the meaning? Again, so if I follow the rule, what happened? I will just distribute that exponent for each and every element. So I can say I'm just distributing this. Actually, it's a multiplication, right? So a to the power 2 times b to the power 2, and if I use the logic here, it makes sense. Whatever inside this thing, inside the parenthesis or bracket, we are multiplying 2 times. I can say a times b, that's 1 time. How many times we have to multiply? 2 times, times a times b. So how many times we are multiplying a? That's 2 times. I can say that a square times b, how many times we are multiplying? That's 2 times here. So that's why this rule is like that, right? So we are distributing it up. Now what about this one? 2 times a square raised to 3, right? So what's the meaning? Whatever inside this thing, we are multiplying how many times? 3 times. So I can say 2 times a square times 2 times a square times 2 times a square. So here, if I consider all the 2's, that will be 2 times 2 times 2. I can say 2 cube, or you can write it as 8 times, how many times a square, a square, a square. I can apply the same rule, right? X raised to m times x raised to n, that will be x raised to m plus n. All I know, the bases are same, so I can say a, then you are just adding all the exponents, right? So it will be 2 plus 2 plus 2, that will be 6 here. So I can say 2 cube times a raised to 6 here. Same, if I distribute this like this same rule, if I just distribute 3 here, it will be 2 cube times a square. Again, I have to distribute times 3, right? So it's the same as 2 cube times a raised to 6. Same answer here. Now let's try to do this question here. So I will just distribute up. You know that s squared times t raised to 4, how many times we have to multiply? That's 3 times here. So if I apply this same rule here, I'm just distributing this 3 here. So it will be s raised to 2 times 3 times t raised to 4 times 3. So this will be, you can write it as s raised to 6 times t raised to 4 times 3. That will be 12 here. Okay, now remember one thing, right? Whenever it's multiplication or division, you can do that. So for addition and subtraction, we cannot do that. Okay. Now, if you want, we can try to take one more example. Let's try to use logic also, right? 5 times 7, the whole cube. Now, I can make, okay, what's the meaning if I do it manually here? 5 times 7, that will be 35 whole cube, right? So if I use the calculator, this is the answer, 42,875, you will get it. Or if I distribute it properly, right? So 5 times 7, how many times we are multiplying the same time number? 5 times 7, 3 times we are doing it. So that's 5 times 7, 1 times we multiplied 5 times 7 times 5 times 7. So if I look at here, 5, how many times we are multiplying? That's 3 times. So I can write 5 raised to 3 times 7, how many times we are multiplying? That's also 3 times. So 5 cube times 7 cube, this is 125 times 7 cube means 343. So if I put the values in the calculator, you will get the same answer. I hope it makes sense. So whenever it's addition, right? If it is like this, 5 plus 7, the whole cube, right? We cannot distribute it. Make sure that when it is addition, subtraction, we cannot generalize, we cannot do that. So it's not like 5 cube plus 7 cube. It's a different answer, okay? This will be 12 cube, right? So 5 plus 7, that's 12 cube. This is not same as 5 cube plus 7 cube. This is wrong. So for subtraction also, it's different, okay? We cannot apply this rule. So I hope it makes sense. Now, same thing for division also. It's the same thing, right? Distribute an exponent over a quotient here. So for example, x over y, the whole raised to n, it means I'm just distributing the n here. So it will be x raised to n divided by y raised to n here. Now, see here, right? Here the bases are different. So I hope it makes sense. And let's use logic. 2 by 3 raised to 4 means 2 by 3. How many times we have to multiply? That's 4 times. So it will be 2 by 3 times 2 by 3 times 2 by 3 times 2 by 3. So if I look at in the numerator, how many times 2? That's 4 times we are multiplying. So I can write 2 raised to 4 divided by, here denominator 3 we are multiplying 4 times. I can say 3 to the power 4. So again, that's the same rule here they are saying. We are just distributing it. Numerator also, denominator also, this exponent. So it will be 2 to the power 4 divided by 3 to the power 4. Same rule here, right? Now, same thing, let's follow this one. So here s divided by t raised to 5, right? Now here I can just distribute it up. What's the meaning? S by t, how many times we are multiplying? That's 5 times, right? So actually what happened here, then if I look at here, 5 times s we are multiplying. And same thing, t also, 5 times we are multiplying. So it will be s raised to 5 divided by t raised to 5. So if I apply this rule, I have to just distribute up. So s raised to 5 divided by t raised to 5. Okay. Now, there are some more rules. I hope these rules are clear now. Now, exponential, let's say, that's called zero law of exponents. Rather than memorizing it, let's try to understand. So what this rule is trying to say, whenever you're getting any exponent raised to 0, right? What is the answer? Always 1. There is an exception, except 0 raised to 0. That's not 1, okay? It's undefined. So remember that. So this x can be any number on the number line, right? For example, 5 raised to 0, the answer is 1. A raised to 0, that's 1. 2.3 raised to 0, that's 1, right? So what's the reason like that? So anything raised, so if I generalize it, anything raised to 0, that is 1, except this anything cannot be 0, right? 0 raised to 0, that's not 1. That's undefined here. Now, what's the reason behind it? Let's try to understand it. So we know some basics rule, right? X raised to m times x raised to n. That's all I see. The bases are same. Then I can just add the exponent m plus n. Then we know the division rule, right? So whenever we are getting exponents, x raised to m divided by x raised to n. So here I can see the basis is same, xx. Then what happened? We subtract the exponents here. So x raised to m minus n, right? So same rules, let's try to apply. Or let's take 5 raised to 0. Why we are saying 5 raised to 0 as 1? The reason here, 5 raised to 0, you can write it as anything. For example, let's say 5 raised to 0, I'm writing it as 5 raised to 3 minus 3, right? Okay, so now what happened here? You write anything 5 raised to 0. For example, you can write 5 raised to 7 minus 7. So anyway, 5 raised to 7 minus 7, that's 5 raised to 0. Backwards I'm solving, right? So 5 raised to 0, we can write any number, 5 raised to 3 minus 3, let's take it. Now actually, this is the same rule, right? So here, x raised to m minus n, right? So what is x raised to m minus n? I can say like x raised to m divided by x raised to n, I can write it. So I can say 5 raised to 3 minus 3, I can say that 5 raised to 3 divided by 5 raised to 3, right? So what happened? 5 raised to 3 divided by 5 raised to 3, it's the same number here. So it's cancelling out, right? So what happened here? What is the number you are getting? That's 1. That's why we are saying, so any number raised to 0, that will be always 1, except 0 raised to 0, it's 1. 0 raised to 0, it's not 1, okay? So you can have any number for x, now except 0. Now take any number, you can write 5 raised to 0. I can think like this, 5 raised to 7 minus 7. So this backwards, if I solve it, so that I can say 5 raised to 7 by 7. So it's cancelling out because it's the same number by same number. So it's 1. I hope it makes sense also. Okay, now let's try to look at the next rule here. Now, negative exponents. So let's say this is the rule. So whenever we are getting an expression x raised to minus n, so you have to remember, I can write it as 1 divided by x raised to m. Okay, now for example, 5 raised to negative 3, I can write it as 1 divided by 5 raised to 3. Or for example, 2 raised to negative 8, I can write it as 1 over 2 raised to 8. Backwards also, 2 raised to 8, I can write it as 1 over 2 raised to negative 8. Now let's try to understand why we are writing like that. Okay, now let's take an example. Okay, so for example, let's say 5 raised to negative 3 times 5 raised to 3. So we just discussed it because it's already in x raised to m times x raised to n, then it will be x raised to m plus n. The bases are same. Then I can say 5 raised to m plus n. So we already know it will be 3 plus minus 3, that's 5 raised to 0. And we already discussed it before. Anything raised to 0, that will be 1 here. So what I can see, 5 raised to negative 3 times 5 raised to 3, what's the answer? We are getting 1 here. So let's divide both sides with 5 raised to 3, right? So I have to do the operation both sides, right? So what happened here? What is remaining here? 5 raised to negative 3, that's 1 by 5 raised to 3. I hope it makes sense here. So same thing. So x raised to negative m equal to 1 by x raised to m. Why we are saying like that? So what about x raised to negative m? So same reason, I hope it's clear. So if I want to just cancel out this x raised to m, so I have to multiply both sides. So when I multiply both sides, see, this is cancelling out. You can see x raised to m times x raised to negative m, right? So same rule, bases are same. So when I simplify, this will be x raised to m plus minus m. What you are getting, x raised to 0, that will be always 1. That's the reason here. Okay. Now 1 divided by 3 raised to negative 2. Here negative 2, so it will be 3 raised to positive number. You have to get it. That will be 3 square. I can write it. So for example, 5 raised to 7, I can write it as 1 divided by 5 raised to negative 7. Because when you multiply 5 raised to 7 times 5 raised to negative 7, that will be 5 raised to 0. That's equal to 1. We know that. I hope it's clear now. Now, Let's try to understand all the rules one more time. There is two more rules are there. We'll try to understand. So what we discussed, the first rule, whenever we are getting an expression x raised to m times x raised to n. So what happened? The bases are same. Then you can just add the exponents m plus n here. Same thing for the division here. Whenever we are getting an expression x raised to m divided by x raised to n, look, the bases are same. Then I can say x raised to, then you just subtracted m minus n. Now third one, distribution, right? So whenever we are getting a rule like this, x times y raised to a, I can distribute this exponent. So it will be x raised to a times y raised to a. Same thing for division also, right? So x by y raised to n means I can just distribute this n here. So it will be x raised to n divided by y raised to n here. Then we discussed it in negative exponents. So for example, x raised to negative n, I can write 1 by x raised to whatever this is negative, then it will be positive. For example, 5 raised to negative 3, you can say 1 by 5 raised to 3. If you want, we can write 5 raised to 7 as 1 over 5 raised to, this is positive, so it will be negative 7 here. Now, let's try to, and then we discuss this one. Anything raised to 0, that we have to get it as 1 here. Now let's consider the remaining two expressions. Let's say we got an expression fifth root of 8. I can write it as in an exponential expression, that will be 8 raised to 1 over this number, that's 1 over 5 here. For example, let's say 7th root of 13. I can write it as 13 raised to 1 over this number, that will be 7. Let's say nth root of 23. I can write it as 23 raised to 1 over this letter, that will be n. That's what it's written here. X raised to 1 over 2, it means it's square root of x. Typically square root of x, we will write that just like this without this 2. Now x raised to 1 over 3 means it's a meaning cube root of x here. Now let's consider a radical expression here, and let's try to apply the same rule, x raised to a times y raised to b. Then what we did it, x times y raised to a here, we distributed. Same thing, x over y raised to n, I can write it as x. Then what we did it before, we just distributed n, so it will be x raised to n divided by y raised to n. Same rule I can apply for radical function also. For example, let's consider this expression, nth root of a by b. We are going to apply same rule here. And we already discussed it, x raised to 1 over 3, I can write it as cube root of x here. Same thing, nth root of a over a times b, I can write it as a times b raised to 1 over n. Then we'll just distribute the a, same here, 1 over n, we will distribute it for a also, b also. It will be a raised to 1 over n times b raised to 1 over n here. We'll take in one example, so it will be clear for us. Let's say we got an expression cube root of 27 times 64 here. Now, if I use the calculator, cube root of 27 times 64, 27 times 64, that's 1728. Take the cube root, you will get the answer as 12. So if I apply the same rule here, what happened here? I can write, say, let's say cube root of 27 times 64, I can write it as 27 times 64 raised to 1 over 3 because it's cube root, same thing. Now then distribute 1 over 3 for each number. 27 raised to 1 over 3 times 64 raised to 1 over 3. So cube root of 27, a number we are multiplying 3 times, we have to get 27. That number is 3. 3 times 3 times 3, you will get 27. So cube root of 27, that will be 3 times 64 raised to 1 over 3. So cube root of 64, that will be 4. 4 cube is 64. So 3 times 4, we are getting the same answer as 12. Same thing we can do it for division also. Nth root of a by b, I can write it as a by b raised to 1 over n. Same, we can distribute n. Here we did it, same thing, here it's 1 over n, same thing, a raised to 1 over n divided by b raised to 1 over n. Same we discussed it, just multiplication and division. Addition and subtraction, we cannot apply this rule. Then one more expression, a raised to m by n, I can write this way, a raised to 1 over n raised to m, because I can apply the power rule, x raised to a raised to b, I can write it as x raised to a times b. We already discussed it, 5 raised to 3 raised to 2, I can write it as square, right? 5 cube we are multiplying 2 times, so 5 cube times 5 cube, that will be already this way, so it will be 5 raised to 3 plus 3, that will be 6. Same thing, a raised to 1 over n we are multiplying m times, I can say a raised to 1 over n times m, the same answer you will get it m by n, a raised to m by n. Why we discussed this point here? Because while solving some question, this will be helpful. Now we have covered all GRE exponent concepts. Now let us solve the official material questions. Why official material questions? Because we will get the same type of language and question format for the exam. So we will solve only official material questions. This will save the video and take pictures and try to solve these questions. 1 to 4 questions, 5 to 7 questions, 8 to 11 questions, 12 to 15 questions, 16 to 18 questions. You may pause the video and try to solve these questions. I hope you have tried all these questions. Let's discuss these questions one by one. I will explain the answers slowly for each questions, but you can focus on the ones you got wrong or speed up the video for faster coverage.